Hello everyone, on another Advent of Code video, day 14 today. And yeah, today we have another problem. This is a serial automata thing, so I think it would be a bit harder task, or maybe I just think. So what is the problem? We have something like a map here, right? So here we have some lines, right? And they are blocking flow of sand. And this is where sand comes, and the sand falls and it creates this kind of pile. So it first stops here, then if there's no possibility for it to fall because there is something blocking, and here is sand already, then it goes left, always first left, then it goes right, and this is how this is. And now if it would fall here, left, left, here, left, and this is how it goes. So sand stockpiles, and then if we go lower, it would like overflow here, as you can see, right? So as you can see, when it's for this situation, then it goes here, here, and it's, goes here, which is shown here. So we have this stockpiling sand, and they ask us when the sand would stockpile so much that it would just fall forever, because here's nothing blocking the sand. And now how we got our input, it's kind of interesting. We have those lines segments, and what's important, this point is always fixed to 500 position, right? And then what we have those coordinates, which is x, y, of some walls, right? So 4984 is one point, 498, which is this one, I believe, and 4. Oh, sorry, it would be this one, all the way through 4986. So this is right. This is the first line, and then starting from the last point, we go 496 to 7, right? This is how we do that, and the other line is on the other line of input, which draws us this thing, right? You can see this, and this was surprisingly easy to implement loading, but I have an idea why they provided data this way. I will try not using this idea because it is probably the longer way to do that. We will try to just implement a simulation of this behavior. If it would be too slow and we will not be able to wait until we got an answer, then we will go for a faster solution, but I would try to avoid this one. And yeah, even if this one would be good enough, I would share with you what I think may work better, but let's leave it for the end of the video. So what do we want to do first? We know exactly that what is the position of our class, but we don't know how big of a surface we're working on. Therefore, I would start off determining this thing, and we would go through. Oh, sorry, I should start with telling you how did I load the input. Very easy. Up until here we just read lines, but this is what happens. So every line I just trim just in case there are some spaces. Then I split on the arrow, right? So it makes sense. And then what I do, so I split my split again on the comma, and on the left of the corner is x, on the right of the corner is y, and this gives me like I collect those guys to vector of points, and the whole thing is vector of points, right? And every internal vector is just a single line. Okay, so we want to make usage of this, but how would I determine the surface area. So I start with having some input. This is my input shape. Let's say something is missing here. Yeah. Yeah, so what do I do? I start with iterating over this thing. Do I want to have the whole vector? Probably. I don't know. So let mood, not mood, let max x, and this is input iter dot flat map. I would go for v.iter. I just want. Does it work? Yeah, that works. I just want to have it. Let me enlarge this. Flatten breakpoints, and I am looking the biggest x. So let me find max by key x. This is what I want for max x, and now I want max y. Just almost the same. Max y. We want it to be this. Right? Okay, so I have my mention of my what is it called, of my surface, but I would call on max x. I would actually go with the bigger of whatever is returned and 500, just in case, because you know I want this to be 500. If the surface would be smaller than 500, I think it would be very easy task. So now I need my surface. I'm wondering if I just want to make it, you know, the two-dimensional vector or not. Yeah, let's do it traditionally. So max x plus 1, why? Yeah, plus 1 because my max x times max y plus 1. Immutable. Then what I do? I would do a small two closures here. So let's let me item on position. That item is, it would take me to things. Yeah, I just wanted to be able to easily address the things from the from my what's it called, array, using my indices, right? Would be usize. I think I can skip on those because they would be figured out later, but doesn't matter. And now what I would do, I need to iterate over like the states of every, like this is the state, and then so this is like, this is state, and the next state is the state with think here, and the next state is think with, you get it. So the state is like position with the next thing locked, right? So maybe let's think about it. Sorry for me being tired, but yeah, today I started this recording like 9 p.m. because of what day. And I would like to do this, but do not expect much. We will use folding of successors. Let's think about that. I don't want to clone this giga surface for sure. I don't want to do that. And because I really don't want to do that, first of all, I would not even return, I would return mutable borrow. Would I would put it like here. I know, maybe not. I want this. Iterate over those things. And then that's why I need to build this surface, right? This is something I completely forget about. So let me just draw it. For line in input.line input. I need for maybe x0 like y0 x1 y1 in line Windows 2. Now they do no, not like they do. We have two cases, either x is constant for our line or y is constant, right? If x0 equals x1, then for and this is a problem here, but we have no guarantees of ordering those guys, and we would go like y0 min y1, and here I want to go with y0 max y1. Oh, something happened with my bindings. Doesn't matter, I can completely ignore Copilot today. So how does it work? The thinking about ranges in the thing about ranges in Rust is that they cannot go from high to low. Ranges can only go from low to high. But yeah, this way we can ensure that the first item is the smaller of two, and the other one would be the bigger one. Oh, I hate I so much used to Copilot. I need to review what's changed. I have upgraded system today, or things today, including my new Vim and its plugins. Okay. And that might be a problem with my bindings, I think. What's What's returned by Windows? Come on. It's Windows. And we have some slices. But they are not arrays, right? So make it this way. Okay, this should draw us our line. I would be very lazy, and it would not be item, it would be IDX. And instead of returning item itself, just return the index of an item. It would make it easier to use it in more contexts. So it would be surface index x 0 y, and here we would have surface index x y0, like that format. Yeah, I just hope it draws me things correctly. I could try print it out, except what kind of vector is our surface? It's, I don't want it to be vector. Should say it would be vector of I just want to have occupied or unoccupied spaces. I at least for now I don't do any more calculations, so it's unoccupied by the start, and then I make those things occupied. This nice. Now I need I will just mutate my surface in a with scan. What would be every iteration? I just want to loop over it, but I want to count my loopings. And I know what would be needed later. I would just go like this. So because I'm exhausted, I would just go with a nasty solution. Yeah, nasty solutions are also good when you have no better idea. And I will just loop as a proper as developer. I loop. Loop is Rust loop for infinite loop, which you can break only by breaking it. So fine for us. And what do we do? We would have mutable position where we have our stunts, new stunts keys. Yeah, new stunts something. Right, nice. Then I would go loop. It's like, it's the worst way you can do that. Actually, I am going like C vibes here, because what I would like to do is just to create successors No, let's be serious. I'm nauseous looking at that. Let me do it like this. This outer loop has some reasonability in it, but I would get rid of this anyway. I just don't want to think about it before it's done. But I would just go with successors. I start with this was the this is the position, and let me go with the position of our sand piece, and yeah, first of all, if surface of this index, so if not surface of this index, so it is empty, right? Of the index with incremented y. Then we just return the index with incremented y. If this is like used, if this index is occupied, then we can try index on the left, which is x minus 1, y plus 1. And the last one we check is this one. Okay. If there is no index, then we return none, which should never happen in our case. No, it should happen at some point. We want to find. Yeah, we are waiting for this every step. So what's wrong? Yeah, we found wait. Successors should give me back this option. Oh, this is a problem. Yeah. Here I want some option too, like this. Okay, and now what I have, I have an iterator, right? And now I can take last, and last would be the final position. But there's a thing, this iterator could be technically infinite. It could be infinite, and it is infinite if it fails to no forever. Let me think for a second. We can fall. We can even, the thing is that we can here go out of bound. So first of all, if y plus 1 is equal to surface to max y. No, if y is equal to max y, then I would also go for no. He would be else, and I would be even funnier. If y would be bigger than max y, I would go for no. But if y is equal max y, I will go for X. I will just increment it. Because, okay, I cannot have any barrier below max Y. Technically, there is no barrier. Okay, now, so I can return, you know, the next position, which is proper. Which basically means that if it happened, I fall like, you know, below, I think it would fall forever. And this is what I am looking for. This means like I'm done with counting. Okay, here I don't care anymore. So it would eventually end always, I think. So now I want to go for last. Okay. Okay. And let xy is this. Now, what I want to return exactly. So I can't start from how many of them. How many units of sun come to rest? Okay, so I just count how many of them were not falling below the lowest place, and it would be easy, I think. If y out reaches max y, I break. This is end of the loop. I just return my counter. Else, I just increment my counter. I should return new size. I somehow think I'm good here. I am not happy with the solution. I'm not happy with this outer loop. I have nothing to return. I mean, what I could do is to make this loop into repeat with like this. I could just repeat it like this instead of the loop, and then I could return a count. Here, what do I do here? What is returned by closure? Repeat with repeats forever, right? So I don't want to repeat with. From a fan. Give me definition of that. Yeah, this is what I want. So here I return known, and here I return some units. So this is just counting number of iterations. A bit better. I am still not happy with the solution. And let's have this. So the problem of the solution is why I don't love it is this I'm wondering. Let's just go with fold. I'm fold lover. I would start folding with I would fold my surface here, right? I go with smooth surface, and here I return known, and here I return some surface. not fault. No. No, it's not. It's if I can go with repeat. But no, I mean I could repeat it forever, but it does make sense. This from FN is good enough. Do not overcomplicate. It's overcomplicated enough. And let's try running this. I have bad feelings, but it is because I don't feel like I am capable of doing this kind of stuff today. But also that's also fun. Do some things when you are a bit less, you know, in the shape. Run. Nice. Yeah. 25. Crash. Why? Could we see our input? I think it's off. Oh, it's empty. That's fun. I didn't test my. Oh, that's why you do trim your things. This would save my day. That's why you do trim your things. Trim is basically free if. Yeah, we went to some infinite loop, I assume. Do I want to draw the whole thing? I don't want to draw the whole thing. I know that my test input, and I just want to draw the test input. Okay. Oh. X in 494. Oh, 492. 305. Or y in 0 up until max y. Let's say this. Something like this. Let me think about this. Oh, here now copilot works. There was something. Maybe copilot gets some strange hint there. Duplicate space. Or maybe Regolith dot would show me more. Let's try to draw it. And now what happens. So let's try to see. What did we get? It does not look correct. Is my index wrong? Say my max 1, let's say it's 3 and this is 4. If my maximum index is 3, then I want it to be 4 height, right? So if my was 4, I want it to be like 5 height. So I guess that this is fine. Then here it's it doesn't quite. But something is like. I mean, first of all, it looks a little bit as reversed. So I want this to go here. That's first of all. It won't run, but oh, okay, this looks a bit better. But the indexes now +1. $62. Yeah. Oh, yeah, stupid. My max X is 500, I guess. 503 is my max X. And this made this not working. Is that correct? It looks very correct. Except I think I found a bug already, not for this input, but here it is a bit more subtle. We would do it like we would cheat. So here we may fall on the left. Technically, I don't think it would happen in input, but we can fall on the left. And in such a case, we want to artificially return something which is, you know, below the place, be below the position. So in this case, we return some x max y +1. This is very artificial thing of if x is 0, it is 0. If my x is 0, yeah, because we cannot have anything below 0. I think we cannot have negatives. And here the same. Here we want to have plus. Okay, that could be. Yeah. This could make it wrong. I'll see if x is bigger than max x. We do the same. We cheat and we turn this. Would it yield me? No. This is not the best way. This is like the rough way. And now what I want to do, I want to... Oh, we go infinite because we do not draw thing on the screen. We need to draw thing. We put it like here we want to go with, and I guess it makes it infinite. Yeah, because let's go with additional print line. Let's go with drawing here. Yeah. What's wrong? Ah, that's you cannot think. Okay. To 502 and 8, which is 100. Why? Let's do this. What? So I mean, this head and stuff. Yeah, they are insisting on going with some crazy stuff. Oh, it's not surface. Now it works. Yeah, 24. Okay, don't want to debug all those things. It was fast for our example input, but I will definitely not try to draw it for my full input. Just give me my answer. I need this draw, so let's leave it here. And let it download me this piece. Okay, it was fast enough. I was worried a bit that it may not be a case. Okay, it was okay. Floor. You don't have time to scan the floor, just in the floor. Okay, like this. That's easy. this worries me, this minus here. Is this possible? It goes below 0. What's my biggest y? I mean, it can form this triangle, right? At most. Think about that. It can form this triangle, and I can easily check my max y. This is something you sometimes do for this kind of puzzles. You just print something to get knowledge. Because my max y, this in my place, is smaller than 500, which is offset of x, I will never go negative with my things. And I also know that I cannot go beyond how big x can be beyond. I need to assume that my max x is my max x maximum of with 500 plus max y. We can go +1 for safety because I don't want the one off, which would kill this kind of stuff. I don't think we'll never have any more need this draw function. The second part is again, oh, okay, we'll go with +5 because there is some offset. It would be +2 or +3, but I am lazy and it won't make the solution too much of max 500. First we need max y. Oh, or not, max y plus 2. Because max y is always 2 below. Right, and here 500 plus max y plus 1 for safety. Now I do my simulation, except here I go a bit different. So if y is my son can never go for plus or for y plus 2. It can, because +2 is a floor. It can go maximum +1. So this is all I need on my simulation. This would stay the same for safety. Now, if y is more than if y is equal to max y, sorry, -1. Because now if equal to max y, this is how far it can go, then it would be known. It cannot go any way deeper. Never ever. We know for the fact we checked our input that this never happens, and same is true for that. We made sure it never happens. This we don't want anymore. So if we achieved our max y, we cannot go further. Now, if xy is equal to our, we want to know when do we reach 500. Yeah, that's something's happened. Sorry. It's equal to 500. This is what you are looking for. Right? Think about it. It would be counting by one and like not willing to go with that. 92 and 92 because we only calculated cents which are there without including the last one, basically. So we need to add one. Always add one because we just do not count this clip here. And we want to include this in our results. So this is the +1. I assume this is an answer. Yeah. I hate having debugs in production or in my final code, so let's get rid of them. Yeah, we are fine. And now one last thing. I told you I would give you a hint how you can approach this to be like efficient in Rust, and how I would do that on production. So if you think about the input, you have like this thing. Let me go with that. I need to switch my screen. Nice. So let's undo that. So okay. So the input is lines like that, right? So what you can do with those lines, you can split them into like those horizontal lines and like this, and these vertical lines. Like, yeah, we have those two vertical lines. So those would be two collections of those things, one collection and second collection. And what do? Then in every step, instead of going one place by one, what you can do, you can actually, let's say this is our 500 point here. Then what you do here, you look your Y position, you find the first line below your Y position, or you iterate for lines after your Y position, and you are looking for the first collision, right? So here you can go, first collision is here, and then you just need to figure out if you go left or right, right? So you check on the left, there is okay, left below, this is something you need to check if there is a collision, which you can do with just collision, line collision, which is very easy to implement. Collision, okay, you finish it here, collision, you finish it. The seconds sand, okay, you go here, and then you try go here, but you don't need to calculate all those things in between, because you can just find the collision to the closest horizontal line. I think that those vertical lines are a bit less, you cannot optimize much. And how to find collision with those vertical, how to basically find collision with line is you have a point, which is integer, and you just need to find if there's a line of this exact position, and you are going this left, right? You're looking if there's line with this exact position, and if your x is in between, basically the same. Except when you are going for y axis, you need to find the first collision. Here you just need a single line to test it. And for these falling ones, what's even funny, you don't even test those vertical lines. You just need horizontals, and this solution would be way more effective. Except you would spend way more time planting this, so I passed on that. Good exercise for someone who wants to go for efficiency. But okay, thank you for today and see you tomorrow. Bye.